name is Najiha Nigar Suraya binti Muhammad Arif Empati with metric number 111210.
Hi everyone, my name is Mashita binti Muhammad Zaki and my matrix number is 110734.
Hi, my name is Kasma Cerida with metric number 110451. I'm from Team 6.
Hi, my name is Hanika Shrina binti Ilham. My matrix number is 110106 and I'm from Group 6.
Objective: to investigate physical properties of lipids and fatty acid.
Materials. The materials are microcentrifuge tubes, spatula, dropper bottles, distilled water, toluene, and 3 selected lipid-based food.
Microcentrifuge tubes. Small plastic tubes used to hold tiny volumes of samples during mixing, separation, or storage. Dropper bottles used to dispense liquids drop by drop so you can control the amount added to a sample. Distilled water, pure water without minerals or impurities, used to avoid interference with the experiment. Toluene, an organic solvent in lipid-based experiments, is often used to dissolve fats or oils because lipids do not dissolve well in water. 3 selected lipid-based food. These are food samples rich in fats that are being tested or compared in the experiment.
2 sets of 3 separate microcentrifuge tubes were prepared. Small amount of solid, 3-fold granules of all the lipid-containing product were added. Their appearance and smell were described in a table form. For set 1, the tubes were added with 1.0 ml of distilled water. For set 2, the tubes were added with 0.5 ml of toluene. All the tubes were kept and shaken to mix. The observation was recorded in a table as their appearance and smell. Results. For the tubes added with toluene, olive oil has clear appearance, ghee has yellow color liquid, and shortening has cloudy white appearance. For the other, olive oil have sharp and pungent smell, ghee has sharp and chemical odor, shortening has stark and strong smell. All of these 3 lipids are soluble in toluene. For the tubes that added with water, olive oil has the oily layer appearance, ghee have the miscible appearance, and shortening have the white opaque appearance. For the other, olive oil has the fruity or grassy smell, ghee has nutty aroma while shortening was odorless. All of them were insoluble in water.
In conclusion, Practical 3 helped us clearly understand how the physical properties of lipids and fatty acids relate to their chemical structure. By observing appearance, odor, and solubility in both water and a non-polar solvent, I confirmed that lipids are hydrophobic and dissolve only in non-polar solvent. I also learned that different types of lipid-containing foods show variations in texture and smell due to differences in their fatty acid composition. Overall, this practical reinforced the idea that lipids share common structural features that determine their behavior and classification, and it gave us a stronger foundation for understanding their biological roles and nutritional significance.
For reflection, this practical helped us understand the physical properties of lipids and fatty acids. We observed that lipids are insoluble in water but soluble in non-polar solvents, which explains their classification as lipids. Comparing different lipid-based food samples also show how structure affects their physical properties.
Hi everyone, in this practical, one of the main things that we learned was about lipid solubility. Lipid does not dissolve in water, but they dissolve well in non-polar organic solvent, which confirm their hydrophobic nature and explain why fat separated from water in many food systems. Apart from that, we also noticed that different lipid content in food have different appearance and odor. These differences came from variation in their fatty acid composition and other molecules. So each sample had its own texture and smell, and it distinguishes. Another important point was how fatty acid structures affect the physical property of lipids. Saturated fatty acid pack tightly together and usually make fats more solid, while unsaturated fatty acid have kinks in their chains that keep the molecule further apart and more fluid. There are few challenges that we faced during this practical. One of it was distinguishing real solubility changes. Some samples needed more time and mixing, so it was not always easy to tell whether a substance had actually dissolved or was just finely dispersed in the solvent. Another difficulty was working with strong food odors. Certain samples produced very intense smell, which sometimes made it uncomfortable to stay close to test the test tubes while observing the result. At last, handling the non-polar solvent toluene was challenging because it has a strong smell and potential health risks. This meant extra care was needed, including good ventilations and careful handling to avoid spills on inhaling the vapor, because it's very dangerous to us.
Suggestions for improving: provide more variety of lipid samples, including samples like pure fatty acids, waxes, or phospholipids will help students compare properties more clearly. Use clearer visual indicators, providing dyes or indicators that highlight solubility differences could make observation more obvious. Improve ventilation since some lipids and toluene have strong smells. Better airflow will make the experiment more comfortable.